All right, so this is chapter 2, and we're actually probably going to be able to fit this entire chapter into one video. We only cover a couple sections, and it should be pretty short and pretty straightforward. In this section, or in this chapter rather, we're going to be looking at linear functions. So these would be straight lines, and most of this should be review. So linear function, straight line, has degree 1. You have an x in your equation with just an exponent of 1, no higher exponents. Slope, which at this point in your mathematical career you have probably heard before. This is the ratio of the vertical change to the horizontal change. And if we're given 2 points, our slope formula is y2 minus y1 over x2 minus x1, essentially the change in y over the change in x. A lot of times in algebra classes, you will refer to this as rise over run. So there are 4 different types of slopes that we can see. A positive slope, so as we move from left to right, my function is increasing, it is getting larger. As I move from left to right with a negative slope, my function is dropping here, it's decreasing. And then a horizontal line has 0 slope, and a vertical line has undefined slope. This fails the vertical line test. It is not a function, so we don't refer to the slope as 0 slope, but as undefined. There are a few different forms of a linear equation that we can look at. Point slope form, this is right here. This is what, in my opinion, is most useful for calculus because we will be using slopes and points and putting them into a linear equation. And in my calculus classes, I generally have students leave it in this form. Probably what you're most familiar with is slope-intercept form. It's very easy to go from point slope to slope-intercept. You distribute your slope and add over your y1 value. General form or standard form, depending on where your constant is, probably see this a little bit more than general form. But these A, B, and C values should be integers, meaning no fractions and no decimals, and where we have the variables on one side and the constant on the other. Horizontal lines have the form y equals and then just some number. There's no x and the slope is 0. A vertical line is of the form x equals a number. There's no y and the slope is undefined. If you are asked to find the x-intercepts or y-intercepts, if you're finding the x-intercepts, you're going to plug in 0 for y. The points have the form of a number and then 0 for the y. They are on the x-axis, and this is where the graph crosses the x-axis. X-intercepts sometimes are also called roots, solutions, or zeros. Y-intercepts, you're plugging in 0 for x, and then the points are of the form 0 and then a number. They're on the y-axis, and it's where our graph crosses the y-axis. So in this first example here, we have 2 points, and we want to find the slope between these 2 points. I find it's helpful if you label your points x1, y1, and x2, y2. And then you can just plug into that formula, y2 minus y1 over x2 minus x1. And our y2 value is -2. Our y1 is -4. And then x2 is 4 and x1 is 6. So a negative times a negative becomes a positive. -2 plus 4 is 2. And 4 minus 6 is -2. So my slope is -1. Onto the back side here, we have a point and we're also given our slope. So in this question, it asks us to write our equation of the line through that point and with that slope in point slope form, in slope intercept form, and in general form. I'm actually going to change this so that it's asking for it in standard form because that's just a little bit more common. So we have a point. I'm going to go ahead and label that x1, y1, and we have our slope. And we're going to start with point slope form. This is the easiest one for us to start with. And just to ensure that I have enough space here, I'm going to start a little bit higher up on the page. So I have y minus y1 equals m times x minus x1. That's point slope form. I'm just going to plug in all of those things. Y minus y1, which is -4, equals m, our slope, -3/5, times x minus 10. And so I'm going to go ahead and multiply here. I have y plus 4 equals negative 3 over 5x minus 10. And that is my answer for point slope form. Now I can go from that form to slope intercept form pretty easily. I can distribute my slope. So I have y plus 4 is equal to negative 3 over 5x. A negative times a negative becomes a positive. That becomes negative, or that becomes 30 over 5, which reduces to 6. And then I can subtract 4 from both sides. And I get y is equal to negative 3 over 5x plus 2. And that is slope intercept form. And then the last one is to get this into standard form. And that's where I want to have no fractions. So what I'm going to do here is multiply both sides of my equation by 5, and that will remove my denominator here. So I end up with 5y is equal to, and then if I'm multiplying this entire thing times 5, well, 5 here will reduce my denominator, and I'll just have negative 3x, and then 5 times 2 will give me 10. I no longer have any fractions. All I need to do is add 3 over, and I have 5y plus 3x is equal to 10, and that is in standard form. Now, the next example here is giving us an equation in general form and asking us to graph it. So there are two ways you can graph something like this. You can get it into slope-intercept form if you like, or you can use the x and y intercepts to help you graph. I'm going to use the x and y intercepts to help me graph here. 2, 3, 4, 5. 1, 2, 3, 4, 5. Couple over this way. So I'm actually going to get this into standard form. Again, it's a little bit more useful for us. So 3x plus 5y is equal to negative 15. So all I did was subtract the 15 over. And now I'm going to plug in 0 for x, and I'm going to plug in 0 for y. So this is going to give me my y-intercept, and this is going to give me my x-intercept. And if I plug in 0 for x, well, this term entirely goes away, and I have 5y is equal to negative 15. If I divide by 3, or I'm sorry, by 5, then I get y is equal to negative 3. For my x-intercept, if I plug in 0 for y, then this term entirely goes away, and I have 3x is equal to negative 15. If I divide both sides by 3, I get x is equal to negative 5. And that little trick there of covering each of those up prevents you from more work to do. This gives you your y and your x-intercept, and 2 points is enough for us to be able to graph. So I have my y-intercept here at 0, negative 3, and I have my x-intercept at negative 5, 0, and I can go ahead and draw my line. In the next example, we have an equation written in slope-intercept form. And they ask us to use the y-intercept and the slope in order to graph. When we are graphing in slope-intercept form, we generally will start with our y-intercept and then use our slope to plot more points. So my slope, or I'm sorry, my y-intercept is positive 4. So 0, 1, 2, 3, 4. There's my y-intercept. And my slope is negative 2/3. That's my rise and my run. Now, before I even go any further and start plotting points, I know that that's a negative slope. So my line should be running this direction. It should have a negative slope. It should be falling as we move left to right. So if I go up to and over 3 to the left, that'll give me a point on my line. Or if I go down to and over 3 to the right, that'll also give me a point on my line. Either direction is fine, as long as you end up with this negative slope with a rise and a run of 2 over 3. And that is the graph of that equation. Now below here, we have some information about parallel lines and perpendicular lines. Parallel lines have the exact same slope, but they have different y-intercepts. Perpendicular lines have opposite and reciprocal slopes. So for example, if you have a slope of, let's say, 2/3, the perpendicular slope would be -3/2. Same slope here, but different y-intercept. So in this next example, it asks us to write the equation for the line perpendicular to this equation here and through this given point. So the first thing I need to do is find, okay, well, what is the slope of this line? So if I subtract 5x to the other side, I have y is equal to -5x minus 4, and my slope is -5. So the perpendicular slope would be +1/5. Again, changing the sign and using the reciprocal. So that's my slope, and this is my point. So I can use point slope form and plug in those values. So I have 1/5 for my slope. I have x minus x1, y1, so -10, and then y minus -1. And simplifying that, I get y plus 1 is equal to 1/5 x minus 10 in parentheses there. If they asked for it in slope-intercept form, this is fine since it didn't tell us what form. But if we wanted to get this into slope-intercept form, I could distribute that 1/5. And 1/5 times 10 is 2. And then I can go ahead and subtract 1 from both sides, and I have y is equal to 1/5 x minus 3. And either one of those would be okay. All right. So this section here, you can see it says section 1. It should actually say section 2 because we just did section 1. Either way, we're doing the whole chapter in one video. And here we're looking at the Cartesian coordinate plane. And again, looking at the graphs of linear functions here. So when we're looking at the coordinate plane here, quadrant 1, quadrant 2, quadrant 3, quadrant 4, this point 0, 0 is called the origin, and these are called ordered pairs or coordinates or Cartesian coordinates. So those are the terms we're going to be using. And then when we are first learning how to graph something, we can use what's called the point plotting method. That's just where you make a table, choose some x values, plug them in, and find the y values, and then plot those points. As we discover more new functions in this class, you will use that point plotting method to help you determine what the graph looks like. The next example says find the equation of the line through 8, 0 and -1, 3. So again, we have 2 points here, x1, y1, x2, y2. And now we don't want to just find the slope, but we also want to write the equation. And it didn't tell us what form, but we'll go ahead and get it into slope-intercept form. So using those 2 points, let's go ahead and find our slope first. 3 minus 0 and -1 minus 8. And we end up with 3 over -9, which is -1/3. So that is my slope. And then I can use point slope form, y minus y1 equals m times x minus x1 to write the equation. So y minus, and you could actually use either one of these points. I'm going to use the first point because having a 0 in there makes the work a little bit easier. Y minus 0 is equal to -1/3 times x minus 8. And y minus 0 is just the same thing as y. I'm going to go ahead and distribute that 1/3. So I have -1/3 x, and a negative times a negative becomes a positive 8/3. And they didn't ask me to do anything beyond that, so that is going to be the equation of my line. In the next example, it says determine if these equations are parallel, perpendicular, or neither. So the way we can determine what they are is looking at the slope. So we can see the slope here is -3. In this form, I need to find out what my slope is. So I have 2x plus 6y minus 9 equals 0. I want to try and get y by itself. So -2x plus 9 and we end up with 6y is equal to negative 2x plus 9. Dividing by 6 everywhere, we end up with y is equal to negative 1/3 x plus 3 over 2. Well, here my slope is negative 1/3. And they're not parallel because these are not the same slopes. They're also not perpendicular because even though they are reciprocals, they're the same sign, and perpendicular slopes should have opposite signs. So these are neither parallel nor perpendicular. And for our last example, we're going to graph another linear equation in slope-intercept form. So go ahead and draw your coordinate plane here. And we have our y-intercept is at positive 5, so 1, 2, 3, 4, 5. And our slope is negative 2/3. So again, your slope should be going this direction. It should be falling. I can go up 2 and over 3 to the left, or I can go down 2 and over 3 to the right from my y-intercept. Either way, those points land on the same line, and that is the equation that you should have. And that's everything for chapter 2. So that is the end of this video.